Good day, everybody. We've been working with functions and graphs, and so the purpose of this video is to show you some of the details, some of the properties that we have for functions and their graphs and how we can define different parts of it, okay? So starting off right away, we name the function by a letter. In this case, it's named f, really exciting name, and it goes up and then down. Now you might say, well, what does this arrow mean on the side? Well, that really means that the graph is extending below, okay? It goes all the way to the left and it goes all the way down. However, just a caution, you need to think of the graph as moving from left to right. Even though that arrow points to the left, it's saying that that's the direction of where that curve goes. But the point, okay, think of it as moving across the graph toward the right anytime we're doing any sort of intervals or descriptions of up or down. So how do I show that this is a function? The first thing you got to do is a vertical line test. And basically what happens is you slide it across the screen and you see how many times it crosses the graph. In this case, it never crosses it more than once. So that means it's a function. Easy enough. Some details about the function that we've been looking at is locating points on the actual curve. So the first thing you're going to do is look for f of 3. Now remember, this means the value at x equals 3, which means directly above the 3 in this case, and so the y value at that point is 2. A little more complicated because if I'm looking at f of negative 4, the curve is below the line. And so I got to go down to match the graph, and it's at a height or depth of negative 3. And f of 5 happens to be the point at the far right, and the value is equal to negative 2. The y value is negative 2. These three locations can be also referred to like ordered pairs, 3, 2. Remember that the number inside that bracket is a 3, okay? It's the x value. And then the negative 4 is also an x value. And the answer you're getting for each of these ones is the y value. So we've located 3 points on our curve. Let's take a look at the next couple of questions. It says, for what values of x, and there's the s there, so that kind of gives you a hint that there was going to be more than one answer, is the function equal to 3? Now you interpret this as saying, for what values is your graph at a height of 3? So don't look at 3 on the x-axis. You have to look at 3 on the y-axis. And you say, okay, when is the graph at this height? Well, to the left, it reaches a height there, and that's where x is equal to 1, negative 1, sorry. And then to the right, it also is at a height of 3, and that's at the value x equals 2. So both of those values are considered to be solutions. Now, if I write negative 1, 2, you might think that's an ordered pair. So the proper notation is to put it in set brackets and say that yes, the x values could be negative 1 or 2. Let's try the same thing for what values of x is the function equal to negative 4. And notice the way I'm reading that. When is y equal to negative 4? And so, oh, sorry, there's the ordered pairs for that other one. So when is y equal to negative 4? So locate negative 4. And remember, you're trying to find out the height of the function. When is the height of this function equal to negative 4? So in this case, it's to the left, and the x value associated with that is negative 5. And that refers to the ordered pair, negative 5, negative 4. So it's really important to pay attention here now. What's the x value and what's the y value? So we've located a whole bunch of points on this graph. There are a couple of other points that are really important that we need to look at, and we'll see them later. There's the zeros and the x and y intercepts. But before we do that, let's take a look at the domain. Now, domain refers to the set of all the x values. So moving left to right, what's the leftmost point on our curve, and how far to the right does it go? Now, this arrowhead, as you can guess, is going to make this thing a little bit more complicated because it's kind of pointing down, but it's also pointing to the left. So in other words, the x values are going to start all the way at negative infinity, and they're going to go all the way to the right at 5. That's how we write it in interval notation. We could also put it in the set builder notation because these are real numbers, right? We've connected all the dots. X is less than or equal to 5. Now remember, domain is left to right. It's the x values. Range is the set of all the y values, and this is all the values from the bottom up to the top. So same way as we did before, let's look at a horizontal line this time. How high does it go and how low does it go? And in this particular case, that arrow again is going to be a little bit tricky for us because that arrow indicates it goes down forever. So the lowest value our graph comes from is negative infinity. Notice I say comes from because we're thinking traveling left to right. So the lowest value is at negative infinity and it goes up to a maximum height of 6, right? The peak of our mountain. And also let's look at that as interval notation. That's where it's going to be y is an element of the reals, y is less than or equal to 6. Okay, as I said a couple of seconds ago, there are a couple of other locations that are very important on this curve. The zeros of f, which is referring to the x-intercepts. In other words, when is this function at a height of 0? When is the function value equal to 0? All of these are synonymous. So, where does it cross the x-axis? Well, it crosses at negative 2 and at positive 5. Whoops, positive 4. Got to know how to count, right? And by the way, it's important to maybe put a couple of extra numbers on your number lines so you don't make those kinds of mistakes. So the zeros are the x-intercepts, and they are both x values. So again, you put them in brace brackets to show that these are a list of numbers, not an ordered pair. What is the y-intercept? Now notice this is singular because a function cannot have two y-intercepts, because that means it must turn back on itself, and that's not going to happen on a function. So the y-intercept is where it crosses the y-axis, and that's going to be way up here at the top at y equals 6. All right? Now start paying attention because sometimes the answers that I ask you for are going to be x values, and sometimes they're going to be y values, and that's going to be a tricky thing. We'll have some tricks for that later. So let's take a look at intervals of positive or negative values. So for what interval is this function positive? I'm coloring it in the screen here. And basically, if you think of the x-axis as sea level, all right, the water level, anything that's above water level is considered to be positive. And remember, you're going to put the interval from left to right, from negative 2 to 4. And we're going to include both endpoints on that interval. Let's take away that color. For what interval is the function negative? So that's this piece here, where it's below. But there's also the other piece, where it's also below the axis. And so we're going to have two intervals for this, which will link with a union symbol. So it's x going from negative infinity to negative 2, right? It comes all the way from the far left infinity up until, or across until negative 2. And then over on the other side, it goes from positive 4 and drops until x is equal to 5. For what interval is this function increasing? Okay, so let's clear the colors here and let's see where it's increasing. It's going uphill. Remember, we're always moving toward the right. Between x equals what? What's the left value here? Negative infinity. So it's going to be from negative infinity until x equals 0. This function is increasing. And it should be pretty obvious, whereas this function decreasing, it's going to be from this portion of the graph. Remember, decreasing means going downhill. So anywhere from x equals 0 until x is equal to 5. And that's basically all the stuff we need to know. And remember, these are all x values. Okay, when we're talking about positive and negative, increasing or decreasing, the intervals you're going to have to give me are x values. So I hope this explains all of the details. You can review this a couple of times, and by the end of it all, everybody better understand it. And then the very last two things, which we're not going to ask too much about, is identifying the extrema. Extrema is the plural of the extremes, okay? So where's the maximum? As we mentioned before, the peak of the mountain, okay? And here is where you give a y value. The maximum height is y equals to 6. The minimum if we travel around our graph, is going to be down at the bottom on the right, which is equal to y equals -2. Now, I know what you're thinking, but sir, it goes a little bit lower on the other side. Yeah, so this is what we call a relative minimum, okay? In other words, it's the lowest number in town. In that area of the graph, it kind of hits a bottom. The concept of a minimum is the lowest number. And on the left side, you might say, well, yeah, it goes down pretty low, but does it stop at a lowest number? How far does this graph go down if you continue on, right, through that? And there is no real minimum for this function. There is no lowest value that we're ever going to hit, okay? So if I say, what is the minimum? You can't really give the minimum for the function. You can just tell me that there's a minimum in this area toward the right. And that's about it. All right, thanks for watching.